question is related to the identification of water. Let me check. Okay, here we go. The equation is about, this question is about, sorry, some elements and compounds. What is the test for hydrogen? Pop sound. It makes a pop sound. Pop sound. When or with the splint. Okay, next one. Describe a chemical test to show that the colorless liquid contains water. What can we use? Okay, which one? Copper sulfate. Anhydrous or hydrous? Anhydrous. Because we have to show the identification, we have to show whether water is present or not. So we use the anhydrous one, which is white in color. And if the water is present, the result would be blue. Okay, what is the other test? What if you don't want to write this test? What is the other test? The cobalt chloride, right? Use the turns pink. Good. Okay. Describe a physical test to show that colorless water is pure water. Okay. This is basically in the practical skills where there is crystallization and to check whether the substance is pure, to check the purity. Okay, so to check the purity of a substance, we need to check their melting point and boiling point, because every compound has a different boiling point and melting point. Okay, so we check their melting points or boiling points. In case of water, we check their its freezing point or boiling point. So if impurity is present, then the boiling point would be higher. Okay, there is a complete science behind it. Let me explain. Okay. Have you ever heard that when we boil eggs, we add some salt in that, in the water? Have you ever heard of this? No? Okay, so it's a common technique used by people that when they try to boil the eggs or anything, they add a pinch of salt or anything that can increase the impurity basically. So they add impurity to water, which increases the boiling point so that eggs can be boiled in a better way. Okay? Okay. Have you ever heard that we add salts to ice creams? No? Never heard of this? Have you ever read the paper, the label of ice cream? Never? Okay, then you have to do it. Check the label of ice cream whether the salt is written or not. Okay? So we add salts in the ice creams to lower the freezing point or to lower the melting point. For example, if the melting point is 4 degrees Celsius, then it would not melt at 4. Rather, it would melt at 0 degrees Celsius or minus 2 degrees Celsius. It won't melt easily. Okay? So we sometimes add salts to ice creams type things which are needed to be like in frozen form to lower their melting point. Okay? That is the general thing. Okay, you need to go, you need to observe this. Okay, so we check their boiling point. That would be our test. And what is the boiling point of water? It should be 100 degrees Celsius. Okay. Um, then there is a table. Sorry, the options are given, and we need to tell which option is or options are correct. So you have to tick two boxes. Okay, a reaction turns involving carbon dioxide causes the cloudiness in the lime water. Okay, so put cross in two boxes to show the correct statement. Okay, if which compounds would like make it milky or what, whatever. Number one, carbon dioxide from when the hydrogen burns. That is incorrect. So we're not going to select this one. Okay. Number two, carbon dioxide forms from the air react to cause the cloudiness. Can this happen? Yes, it can happen. So we put a cross in this one. The cloudiness is caused by the formation of calcium hydroxide. No, it is because of calcium carbonate. The cloudiness is because of calcium carbonate. Okay, the cloudiness is caused by the formation of white precipitates. Yes, it forms white precipitates which makes it cloudy or milky. The reaction in the lime water is example of oxidation. No, no. So it's 2 and 4. Okay. Um, let me check if I can find some other type of question. We do have. Okay, this is very common by the way. The experiment that I'm going to show you is related to diffusion as well, the reactions as well, the many things are included in this one. Many. This one. On one side we have to take the concentrated hydrochloric acid, on the other side we have to take the ammonium salt, ammonium solution. You'll find this example in many topics. Okay? Basically we use this example in diffusion because of its different atomic or the molecular masses. Okay, the white precipitate forms near this hydrochloric acid. That's a different story. Why does it happen? Okay, identify the white solid. If it's HCl and ammonia, what would it form? Okay, ammonia and hydrochloric acid. Ammonia, hydrochloric acid. Okay, let's let's do it quickly. Okay, HCl. What is this? What ion would be formed by ammonia? Let's say it form hydrogen ion, chloride ion, and we have ammonium ion. Okay, what would be product now? Ammonium chloride. If you find difficulty in identifying it, just make ions and then react those ions. Okay? What does the diagram show about the speed of ammonia molecule compared to the speed of hydrogen chloride? So basically the question is related to this. We give example for this very specific like thing. Okay. So why does which would have a greater mass or which would have a lesser mass? So when we calculate their masses, the mass of HCl is 37.5, okay, and ammonia is 17. Okay, when we add their masses, nitrogen is 14 plus 3 hydrogen, 1 each, it would be 17. And in HCl, hydrogen is 1 while chlorine, oh sorry, it would be 36. It's 35.5 plus 1 is 36.5. So which is heavier? Hydrochloric acid. So can it travel, which would travel more, the lighter thing or the heavier? The lighter. So we will say because ammonia has a lesser molecular mass or being a smaller molecule would travel or would diffuse faster as compared to hydrogen chloride. Okay, ammonia molecule diffuse faster than hydrogen chloride. So if they have asked you, if they ever ask you about the why it's happening, then you have to tell because the ammonia has a lower molecular mass. Okay, and I'm using the word diffuse because they have given us a very clear word in the question that this is related to diffusion. So we have to think wisely what the examiner has given us in the exam. Okay? Okay, state the main hazard. Since we are using hydrochloric acid, so what can be the hazard? What can happen if we are using the, or if we are touching the acid directly? It's corrosive, so what should we do? Use glove, wear gloves. Okay. Mm. Shall we start with the next topic now? Okay. So the next topic is, I guess we are done with organic ones. The inorganic chemistry, we are done with these. Okay. The next one is the physical chemistry or organic chemistry. Which topic do you want to start with? Yes, we can. Okay. But before starting organic chemistry, let's have a quick review on this one. Let's start organic chemistry. Just give me a minute.